Okay, we will go with the first problem. For the following system, determine whether the system is linear, time invariant, memoryless, causal, and stable. This is a standard problem and it is important also. Okay, here a system it is given, that is h of x of n is going to be equals to x of n minus nd. It is delayed. Nd means delayed by some samples, some time. It is delayed but with the time period of nd. That is what it is of nd it is representing. Okay, then what is the solution? We have to, for this equation we have to tell whether it is having this, whether it is a linear, time invariant, memory, or else causal, and last one is of a stable. Okay, we'll go with checking one by one. In the given equation, the system h is the system operator. We come across this h. Okay, then our output is going to be taken as y of n is going to be h of x of n. Means in the system representation we taken, the input is going to be given as x of n, the input what I am going to give. The operator it is going to be taken as this is h, and the output what I am going to get is of y of n function. Okay, here I wrote the same. The output is of y of n, that is going to be based on the operator h. The processing is going to be done for the x of n. For that reason h of x of n. If they given it's okay, or else you can write this one. Okay, then it's a given function is of, it's going to be delayed by some interval, that is x of n minus d. First we will go for the checking for the linearity. Linearity means x of n as weighted sum of two signal, that is x1 of n and x2 of n. If I am going to consider here, I am going to consider this, then x of n is going to be a x1 of n plus b x2 of n. If I apply this x of n to the operator h, that is h into a x1 of, instead of this x1 is going to be replaced with the this factor what we written. Okay, to find the linearity of the system, that is a x1 of n plus b x2 of n. That is going to be taken as, this is a is a constant value. I can apply the h to the x1 of n and also for the x2 of n also, because it is also a linear function. For that reason, so I can write here as a h of x1 of n plus b h of x2 of n. The system is linear. If it is system, if I able to write like this, then the system is going to be a linear. If it is not able to write like this, it is going to be a non-linear function. Now we will solve for this. It's a given equation. I am going just using of this equation here again, h of a x1 of n plus b x2 of n. That is going to be, what is our x1 of n here in the equation? It is taken as x of n minus nd. So you h of x1 of n, this h of this whole I can write here as a x1 of n minus nd plus, same you can use this equation, or else I'm substituting here. Okay, instead of here x of n is there, if I write x1 of n, what is the change is going at the output? Here also it's going to be changing to the x1 of n of n minus nd. Same thing I am writing here. Just substitute wherever it is x1 of n, go and substitute for x1 n minus nd. If it is of x2 of n means, what I can write? If it is of x2 of n, here I can change with x2 of n minus nd. Same thing I read here. I wrote a x1 of n minus nd plus b x2 of n minus nd. This is nothing but what? This is a, this is the operator. Based on the operator I can write as h of x1 of n plus b h of x2 of n. In the reverse fashion I am writing. Okay, is this able to write in the same? Yes, I can able to write the signal. So then I call the system is a linear. Then the next parameter is of time invariance. When I call the system is a time invariance, if y of n minus n naught with some delay n minus n naught, that is going to be equals to h of x of n minus n naught, the system is time invariant. If it is going to satisfy, then I call the system is of a time invariant. If it is not satisfying, then I call that as a time, it's not a not time invariant system you can write, or else time variant system you can write. Okay, then h of x of n is going to be, it's a given equation. What I'm going to do, I'm changing the time period. Instead of n, I'm going to change here it as this. I'm changing, that is n minus n naught, that is I can write here write as this n minus, I'm writing minus n naught this side. Okay, then this is nothing but our y of n minus n naught, that is going to be x of n minus n naught, substitute here, minus nd. Same thing again, you can write directly or else you can write two times, no change you will come across here. Therefore this is nothing but y of n minus n naught is going to be taken as, what I can write here is also a delayed function. This much delay is going to be happening here. So the total delay I can take here is of a n minus n naught. So we can call the system is of a time invariant system. The delaying function nd also delaying function, n naught is also a delaying function. With respect to time only it is going to be changing. For that reason this system is of a time invariant system. The delaying is going to happen with the symmetric operation with the, what is the time is going to be changing, for that reason. Next, what about the third one? That is our memoryless. H of x of n is going to be x of n minus d. It's given for us. The system is not memoryless unless nd is going to be 0. Means not memoryless means it is having, if I substitute for nd is equals to 0, what it's going to be? If I substitute nd is equals to 0 in this means, I'll be getting as x of n only. What is x of n signal? X of n is the present value, right? If I substitute for the nd is equals to, okay, plus 1 if I substitute, what I will be getting? If I substitute nd is equals to 1 means n minus 1 I will get. N minus 1 means this is the past value, right? Means if it is having the memory, when I substitute nd as minus 1, what it's going for? N minus of minus 1, then I will be getting as n plus 1, right? N plus 1 means it's of a future value. For the past value it is having the memory, for the future also it is having the memory, but at the point of nd is equals to 0 it is memoryless system. Okay, means at nd it is of a memoryless, for other values of nd it is having the memory. You can write anyway, the theory you can write in the way which is convenient for you. Okay, then what about the causality? When I go for the same, based on this only I can tell here. What about the causality? If nd is greater than or equal to 0, the system is causal. Otherwise, it is not a causal system. It should be greater than or equals to 0. It should not consist of the future value, right? If it is of nd should be greater than 1 means 1, 2, 3, 4 or else 0. For that condition only the system is a causal. Otherwise it is of a non-causal. Then what about the stability? This is consider x of n. It is bounded with the bx with some values. Bx is with the some bounded values. That values are less than infinity only. Then y of n, that is going to be, what is our x of n here? X of n minus nd. So again that is within a bounded values only I will be getting here for the system. So that is also within the limit of infinity. Therefore we can tell that the system is of a stable. Almost all the systems are stable with a particular time. Okay, the design what we are going to design of a system, we have the main consideration is we should design such a way that the input what we are going to give, we should get the exact output. There may be a small variation is going to be, but the system is going to be a stable only. Okay, this is about the 5 properties it is going to be. This is important. Based on the properties, 6 marks will be asking in the exam. This is one example. In the same way we go for the next example, that is determine the system property of the system, that is t. The operator is of t here. Instead of h it is given as t. Of x of n is going to be g of n x of n, where t is the system operator. First we will go for the checking for the linearity, that is t x of n is going to be g of n x of n. What you have to perform for x of n so that it is going to be linear, we should go with the undergoing with the operation a x1 of n plus b x2 of n. If I am going to be done, then if it is equal, then it is going to be a linear function. That what I can write, instead of x of n I am substituting here as a x1 of n plus b x2 of n. G of n is a constant. Okay, then if I multiply g of n for both the parameter, so I'll be writing as a g of n x1 of n plus b g of n x2 of n, right? This a g of n x1 of n is nothing but, observe here I'm showing here, t x of n is of g of n x of n. If I change to t of x1 of n, what is the change is going to be at the output? It is also going to be changing g of n x1 of n, right? For that reason what I can write here, instead of writing g of n x1 of n, I can write as a into t x of x1 of n in the same way, plus b t x2 of n. It's a simple, just remember you have to substitute here, you will be getting the equation here. Therefore a system is going to be a linear. Then if it is time invariance, to check the time invariance, t we are going with the delay of n minus n naught. We have to substitute this. What is the change? It's going to be changing for the x of n minus n naught. Then you apply for the g of n in the next, that is y of n minus n naught is going to be g of n minus n naught. This is in the operator only, means it is in the operator only. What is the output is going to be? That is y of n minus n naught. Okay, this is function in the operator only. Okay, for that reason here I didn't wrote. When it is going for the output y of n minus n naught, it's going to be, it is going to affect for the g also. Okay, for that reason g n minus n naught into x of n minus n naught. Therefore what is expecting, it should not change with the g of n and x of n, but here it is going to be changing for the g of n minus n naught also. Due to this it is not going to be equals to t of x of n minus n naught. So therefore what I can write here, system is not time invariant, or else the system is time variant. You can write here. Then what about the memory? Since the value of the output depends only on the present value. Why? Here if I substitute for n is equals to 0, what I will be getting at n is equal to 0? G of 0 and x of 0 also. If I substitute for 1, if I substitute for 1, means n is going to be 1, g of 1, x of 1, means it is only depends on the present value of the input. So the system is memory less only, it is not having the memory. What about the causal? it is depends on the present value only. So I can tell that the system is having the causal. Here I wrote here as, since the output depends only on the present value, that is stressing only on the present value of the input, therefore the system is causal. What about stability? Consider x of n. This is a standard equation. You have to write all, whatever the problem it is given, you have to write the same steps. X of n is within the bx. Y of n is going to be, what is our y of n? G of n into x of n within the bounded g of n, bounded for g of n and also for the x of n. Therefore g of n, if I multiply it with bx, is only for the x of n. For that reason g of n into bx here I wrote. It is in the bounded output only we got, so the output is bounded only if based on our g of n. If it is bounded with the output, then we call that the whole system is of a stable. Means for this problem it depends on our g of n. If it is stable, then our whole system is going to be stable. If it is not stable, again the whole system is going to be unstable system. For that reason here it is wrote, it depends on the g of n. Okay, that is about the stability. Next problem, here determine the properties of the system. For the system, that is t x of n is equals to x of minus n, it is given. What you have to do? We have to check for the linearity. For the linearity, t x of n is going to be x of minus n. Substitute x of n as a x1 of n plus b x2 of n. Here a into x1 minus n plus b into x2 minus n. This I can write as a t into x1 of n. Here if I write x1 here, here also will be writing as x1 only. For that reason a t1 x of n plus b t x2 of n. Therefore what I can write? System is a linear. What about time invariance? That is x of n minus n naught, it should change. Here x of minus n naught. Then y of n minus n naught is going to be, minus is there. For the n it is going to be changing as n minus n naught. Then you substitute here. So what will be getting? X of minus n plus, because minus of minus plus n naught you will be getting. Is that again check here, the time change is different here. For that reason it is not going to be equals to t of x of n minus n naught. Remember only one point, directly don't substitute here as for n minus n naught. When you are writing the output factor, then you change here. Okay, remember this point, or else you can write directly of this equation. Okay, then what I can tell of this, the system is not a time invariant system, or else the system is of a time variant system. Then what about the memory? If n is greater than 0, means for the positive values, the system is not memoryless, means it is having the memory. Future value it is going to depend. For that reason substitute, just you substitute here. When I substitute for n is equals to 1, minus 1 you will get, it is of a past values, right? Means it depends on the past values. So then I can tell that the system is having the memory. Not memoryless means it is having the memory, that's what. Then what about the causal? If I substitute for n is equals to minus 1, what I will be getting here? I will be getting as x of 1. For the past values, it is giving the present value. Therefore, the value of the output signal at n is equals to minus 1 depends on the value of the input at n is equals to 1. Therefore, the output depends on the future values, means next values. I am giving as a minus 1, but it's giving the output as the next values, right? future values of the system. Therefore, the system is non-causal. When you are going to check the memory and also of a causal, just you substitute for n values. N value as take as 1, 0 and minus 1. Then it will be easy to decide whether it is having the memory or else the causal. For any of the problem it is given. Okay, if you know about the how it is going to be done, you can write directly whether it is having a memory or causal. Okay, then what about the stability? Almost it's stable only. Therefore, if x of n is less than or equal to bx, then y of n, the output, is within the bounded of x of minus n, that is also within a limit of bx only. Therefore, the system is stable. Next problem, here it is given, that is t of x of n is going to be x of n plus u of n plus 1. Here the addition with the unit step function with the delayed function, the delayed by minus 1 time. Okay, we will check with the linearity. X of t of x of n is going to be, here it is given equation, here I wrote directly. Then substitute for x of n. The same steps are going to repeat, okay, for all the problems. X of n minus x1 of n plus b x2 of n, that is going to be a x1 of n plus b x2 of n. Only x1 of x of n I am going to substitute, not for u of n plus 1. Okay, u of n plus 1 remains as it is. So from this, the extra point, it is not going to be changing. Instead, it is going to be adding with the system. So it is not satisfying the linearity. We can tell that it is not going to be equals to a t x of t of x1 of n plus b t of x2 of n. It's not satisfying this condition. Therefore, the system is non-linear. If it is given in terms of a multiple function, instead of plus, if it is given in terms of a multiple, means I can multiply for both the function, then I can tell that the system is of a linear. But here it is going to be addition operation. For that reason, it is of a non-linearity. Okay, then what about the time invariance? This is the given parameter. Just you substitute y of n minus n naught here for n minus x of n minus n naught. It is going to affect for the u of n when it is coming at the output. I hope you are making the difference how I am writing here. Okay, I am applying at this for the dependent. It depends on the x of n. For depending, I am writing in the next step, changing the time interval n minus n naught plus 1. Again, it is not going to be t of x of n minus n naught. Therefore, the system is not time invariant. Then what about the memory? If I substitute for n is equal to 0, here you will get 0, x of 0 plus u of 1 you will get. If I go in substituting n is equals to 1, x of 1, u of 2 you will get. If I substitute n is equals to minus 1, x of minus 1 plus u of 0 you will getting. Well, therefore, the output y of n depends only on the present value of the input. Therefore, the system is memoryless. Okay, don't depends on the u of function. Okay, unit step function, only at that particular time it will be coming with the one sample only. Okay, if I multiply with x of n, here we don't know what is our x of n signal, whether it is it is having full values or only of the part of the signal is there. We can't assume of that. For that reason, what we'll tell, only depends on the x of n. When comparing with the x of n signal with the unit step, which one is having the more weightage in the general, in a general way thinking, means x of n is having the more weightage than with the u of n plus 1. Okay, based on that we have to check here. Based on that we can tell here as a it is having the memoryless. What about the causal? Since the output depends on the future values, therefore it is having the causal. Okay, then what about the stability? If x of n is less than or equals to bx, then y of n is going to be x of n plus u of n plus 1 with the bounded input only. Therefore less than or equals to x of n is of bx plus u of n plus 1. The output is bounded if and only if what about our u of n plus 1 is bounded. Therefore again in the previous it depends on g of n, here it is depends on the u of n plus 1 function. Hence the system is stable. Next problem, it is asked in the exam. Almost all the problems asked in the exam. Okay, just go through how to identify the each property. Next, determine the system properties for the system, that is y of t is going to be e power x of t signal, exponential signal. It is here, it is given for us. This is the given equation. Therefore let y of t is going to be with the operator. Here it is not given as we have to use h operator or t operator. It depends, it left to you. You can use t or else h. Okay, therefore here I taken as t. X of t is going to be given as e raised to xt. For the linearity, t a x1 of t plus b x2 of t, that is going to be, so where is our x of t? Here it is. Changing for x of t with the same values here. I'll be getting as a x1 of t plus b x2 of t. When I expand this, what I will be getting? E power a x1 of t into, right? It is going to be multiplied with the e power b x2 of t. Therefore, we are not going to get with the linearity property. So it is not going to be equals to a t x1 of t plus b t x2 of t. What you can decide from this? The system is of a non-linear. Then if I check with the time invariance, t of x of t minus t naught, that is going to be e power x of t minus t naught. Y of t minus t naught is going to be e power x of t minus t naught, means it is going to be changing with the time. So y of t minus t naught is going to satisfying the condition, that is t of x of t minus t naught. Therefore the system is time invariant. What about the memory? The values of the output signal y of t depends. If I substitute here t as 0, e power x of 0 you will be getting. If I substitute 1, again you will be getting 1 only. Depends only on the present values of the input signal x of t. So you can write here as system is having memoryless. What about the causal? It only depends on the present value, or else it's not does not depends on the future value. We can tell the system is causal. Remember one point when you are writing the causal, if it is depends on the present value only, means then the system is of a causal. You can write of that if you are confusing with this line. Okay, then what about the stability? Of course it's going to be stable only. Let x of t bounded with the bx, then y of t, that is the given function is e power x of t, is less than or equal to bx. If input is bounded, the output is also going to be a bounded only. Therefore the system is stable only. Okay, we'll stop here. We'll go with the next problems in the next class.